Okay, so what I'd like to do in this video is we're still talking period changes, but we're not going to do things with nice even numbers, right? Because we're dealing with quadrants, so things happen in fours, and that's a nice even number. So what happens if we have some odd numbers, right? What do we do? So nothing, really. It all remains the same. So here b is equal to 3. This is greater than 1. So what are we expecting? We're expecting a horizontal compression. What's my new period? Right? Well, it's 2 pi over b, which in this case is 2 pi over 3. So what happened normally between 0 and 2 pi is now happening from 0 to 2 pi over 3. Now that sounds a little ugly, but we're going to be okay. Watch what happens, right? And so notice that the period has gotten a lot smaller. So about a third, what used to happen in one full rotation, right, is going to happen 2 pi over 3 takes us, that's about, in terms of an arc length there, 2 pi over 3 is, over where? Over in quad number 2, right? So we're basically like about a third of a rotation through. Alrighty, so let's see what happens. So again, it's all about, rather than trying to figure that all out, just manipulate data points. So what's our big, what are our big ones for sine? 0, 0, pi over 2, 1, pi and 0, 3 pi over 2 and negative 1, and then 2 pi and 0. And as we did here, we're going to basically divide everything by 3. Of course, if I divide by 3, that means I'm actually multiplying by 1/3, right? Because that's what division means. So we're basically taking 1/3 times all those things there. So what are my new points? Well, the y values aren't changing, right? We're not doing anything to those guys. But 1/3 times 0 is 0. 1/3 times pi over 2 is pi over 6. 1/3 times pi is pi over 3. 3's cancel out, and we have pi over 2. And what we get there is 2 pi over 3. So my endpoint to my endpoint. So we got it. And so all we have to do is pay attention to scale. Again, along the y-axis, we can be 1 and negative 1. But along my x scale, we're going to scale it in terms of pi over 6, pi over 3, pi over 2, and 2 pi over 3. And somewhere over here, right, there eventually would be pi, and I'll come back to that in a little bit. So what's our graph look like? Well, we start at 0, 0. At pi over 6, we're 1. At pi over 3, we're 0. At pi over 2, we're negative 1. 2 pi over 3, we're back at 0. And then at 2, oops, I think I messed up. Yeah, no, I got it. So here's basically our graph, right? So this in red is the graph of sine of 3x. And there's pi, so just coming way out here, somewhere out here is 2 pi. And we know under normal circumstances, right, sine is looking like this, right? So there's basically a sine graph in blue. So you can see what we've done is taken that graph and we've compressed it into about a third of what's actually happening, right? There'd be another third if we just kept gluing that on. So it'd be a cycle of 3, a frequency of 3 as we get there. Okay, but there's one cycle with some nice marked extrema points, right? I clearly know where the extrema are. I clearly know where the intercepts are, right? Everything is nice and neat. It's all about manipulating the big guys, all right? What happens on all our quadrants. So it doesn't matter if they're nice values for B or hard values of B. It's just the same stuff. I'm just hoping, because I kind of forced you guys to work with fractions, I hope you guys understand why I was making you guys work so hard with fractions so that this can be a little easier to look at. Hopefully we have a nice payoff. So what about cosine of 5x? Well, here b is equal to 5, so it's greater than 1. So we're expecting a horizontal compression again. And so this horizontal compression, our new period is 2 pi over b, and so this is 2 pi over 5. So what used to happen from 0 to 2 pi is happening from 0 to 2 pi over 5. So it's even shorter than the one we just did. So it's really being packed in. So again, rather than trying to figure out where all the data points are, just manipulate the big ones, right? So what are our big values on cosine? Well, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. Those are the big guys on cosine. So what's going to happen in the new graph? Well, we're going to be, right, we're taking everything and dividing it by b, so we're dividing it by 5. But that means we actually multiply by its reciprocal 1/5. So all of these are going to be multiplied by 1/5. And I know they get a little nasty, but that's okay. All right, and so what are our new data points? We'll just mess around with our scale. These don't change. And then this is 0. That's pi over 10. This is pi over 5. This is 3 pi over 10. And this is 2 pi over 5. So those are pretty nasty. All right, but just in terms of scale, there's 1, there's negative 1, and just match that as your scale. So right here's pi over 10, here's pi over 5, here's 3 pi over 10, and here's 2 pi over 5. And of course, somewhere way down the road there, right, we're not even close to pi yet, so we haven't even, we're really scrunched in. And so we have 0, 1, pi over 10, 0, pi over 4, negative 1, 3 pi over 10, 0, 2 pi over 5, 1. So there's one cycle. All right. Oh, I put it in blue. I'm sorry. But there's basically what cosine of 5x looks like. I should have put it in red and been consistent. What's the normal cosine graph look like? It's a lot longer, right? It's way, I mean, if that's 2 pi over 5, 2 pi is way the heck out here, right? And so as perspective. So that cosine graph would really be right here. So we've taken that normal cosine graph and we've packed it in, right, to almost a fifth, all right, of a 2/5 of a rotation there, if you would. So we're really packing that in. I think we're barely 2 pi 6 over 5, so we're just barely over the first quadrant. We're a little over 90 degrees in terms of that, and so we're really packing everything in quite nicely. Alrighty, so there you have it. That's how we impact period and how we manipulate graphs for periods. So what do we now need to do is put amplitude and new periods all together. But we'll do that in some new videos coming soon.